You are listening to The Vocal Technologist. Spoken tech for your ears.
Okay, hello and welcome. If you're anything like me, you're probably feeling that constant pressure, right? Trying to keep pace with just how fast things are moving in data and AI. The information overload, it's real. So our mission today here on Vocal Technologists is really to help you cut through some of that noise. We've got some fascinating sources lined up, and we're going to pull out the key nuggets, give you a bit of a shortcut really to getting up to speed on some genuinely cutting-edge stuff. I'm actually really curious to see what stands out.
Absolutely. And it's more than just knowing what's happening. We want to connect the dots for you, see the bigger patterns, understand why these things matter and how they might, change the game.
Okay, great. Let's maybe start with something that sounds, well, almost impossible. Data efficiency at an extreme scale.
Yeah.
I mean, get this. Crawling 1 billion web pages in just over 24 hours.
Yeah.
And this isn't science fiction. Our sources suggest this is the kind of thing happening, or possible, right around 2025, using a modern approach, of course.
Right. And the key insights there are a mix of things, super efficient parsing, obviously, but also an absolute need for serious fault tolerance. Because, let's face it, at that scale, things break.
Oh, for sure. Something's bound to go sideways.
Exactly. And also really sticking to web politeness standards. You can't just hammer the internet. But here's maybe the surprising part, the sort of counterintuitive finding.
Okay.
While you might think, okay, billion pages, spread the load wide, disaggregate everything, they actually found more success, more efficiency with a tighter cluster of really optimized nodes.
Interesting. So concentrated power rather than spreading it thin.
Kind of, yeah. For the complexities of the modern web, this focused approach apparently proved more robust and efficient. It's a bit of a shift in thinking.
Huh. Okay, so that's getting the data. But efficiency doesn't stop there, right? You mentioned savings.
Exactly. Which brings us to something called Parquet Content-Defined Chunking, or CDC. Now, this tech is getting built into tools people use every day, like PyArrow and Pandas. And it works with something called the AZ storage layer.
What's that quickly?
Think of it like Git, for version control, but designed specifically for massive data sets. It helps manage versions and store data really efficiently.
Got it. Like Git for data. Makes sense.
Precisely. So integrating Parquet CDC with Zet means, for data engineers, potentially huge savings. We're talking less data to transfer, less storage needed.
How does that work?
The core idea is actually quite simple, but brilliant. It only looks at the chunks of data that have actually changed. So you tweak one small part of a massive file. You only handle that tiny changed chunk, not the whole enormous thing again.
Wow. Okay, I can see how that saves money. Especially for something like, say, Hugging Face Hub uploads.
Absolutely. Makes those kinds of platforms way more efficient for moving large files around.
That sounds fantastic.
Yeah.
But quick question, does only handling chunks add complexity? Like for keeping track of versions or making sure the data is still intact, especially at, petabyte scale.
That's a really good point. But the Zet layer is actually designed for exactly this. Versioning is kind of baked in. So you get the savings and robust Git-like version control. It actually aims to simplify managing versions at scale, not complicate it.
Okay, that clears that up. So we've got efficient crawling, smart storage, but then you need to find things in all that data, right? Make sense of it.
Right. And that leads into embedding intelligence directly into data systems, which brings us to dimension importance estimation, or DIME.
DIME. Okay, what does that do?
It's a technique to make dense information retrieval better. Think search, but smarter. It works by basically figuring out which dimensions of a query embedding are just noise, low signal stuff, and it strategically removes them.
Like tuning out static on a radio.
That's a great analogy, yeah. It helps the AI focus on the important parts of the query to find relevant information. And here's the real little part. You don't need to retrain your big AI models or renex your massive data sets to use it.
No retraining. That's huge.
It is. And tests showed certain methods worked best, like PRF using a centroid from top results and LLM using synthetic document embeddings.
Okay, very interesting. Smarter searching without the massive overhead. Now, if we connect this, making sense of data with handling it responsibly, that seems crucial.
Absolutely critical, especially as AI gets more powerful. Which brings us to Meta's work on policy zones and their privacy-aware infrastructure, or PAI.
Right, privacy at scale. That sounds like a massive challenge.
It is. They're dealing with exabytes of data, both batch and streaming. PAI is about enabling really fine-grained control over why data is being used. Purpose limitation, they call it. and transparency.
Purpose limitations, like data can only be used for approved reasons.
Exactly. They use something called governable data annotations and unified tools to kind of automate compliance. This helps prevent data just getting stuck in silos, but ensures it's used appropriately, even in really complex ML workflows with lots of dependencies. It's about building privacy into the infrastructure.
That's impressive. Balancing innovation with responsibility.
It raises that key question, doesn't it? How do you manage these colossal amounts of data responsibly without completely stifling the ability to innovate and learn from it?
Yeah, it's a tightrope walk. So, reflecting on all this, what does it mean for you listening in? We've gone from that mind-bending scale of web crawling and the surprising cluster approach to the clever savings of Parquet CDC, improving costs and versioning. Then we saw how Dime makes information retrieval smarter without retraining, and finally, Meta's really robust framework for embedding privacy deep into massive data systems.
Right. It feels like all these threads making things faster, smarter, more efficient, and safer are really starting to weave together.
It definitely seems that way. They're all pushing towards interacting with huge amounts of data more intelligently and securely.
Exactly. And maybe the final thought to leave you with is this. Consider how these different advancements, from optimizing data chunks to enforcing privacy rules and AI pipelines, how they're all converging. They're not just isolated improvements, they're collectively redefining what's possible, yes, but maybe more importantly, what's responsible in this age of truly massive data and pervasive AI. How will these foundational shifts start to shape your own digital world? Something to ponder.
Spoken Tech, for your ears.